Hello everyone, welcome to Drishti IAS in the new series of 100 days preparation for your prelims 2026. And you can see I am discussing the topic of science and technology for your prelims examination. And we start this video by some context that what are going to be discussed in this video. And this is the orbital mechanics. The first part we are going to discuss about the orbital mechanics. Second part we are going to discuss about vehicles, means our launch vehicles which we have, and also we want to know about the ISRO mission milestones. Under the orbital mechanics we are going to know about the characteristics of LEO, MEO and GEO, and also we have to look at the Sun-synchronous orbit, but the most important perspective is geostationary versus geosynchronous. Because UPSC is always very interested to ask the question from the orbital system. And also in this video we are going to talk about launch vehicle. We have PSLV, we have the GSLV Mark III, and also we have SSLV, the new launch vehicle added with ISRO. And under this section we are also talk about the fuel system of our rocketry, means our solid, liquid and cryogenic fuel type. And also in this video we are going to talk about the escape velocity principles. But the third one, which is very interesting and very hot topic for your prelims, and this one is ISRO mission milestones, and the most important one is Gaganyaan, which is a manned flight. We planned for it, but already ISRO done the Aditya L1 mission, which is a solar mission, and also for the Chandrayaan 3 we know it. So these are the context that we are going to talk about in this video. So we start from the Earth orbits, and you know that Earth orbit means the circular path which is present around the Earth, and we place some satellite over it, and this satellite can move around the Earth. So these are basically known as your orbital systems, and the first thing is known as your low Earth orbit. We also called it polar orbit. What we called it? Polar orbit. Because mostly when we place some satellite in low Earth orbit, so basically these satellites are moving around the poles of Earth. If my hand is like Earth and this is your North Pole, this is your South Pole, so we want to move the satellite something like this, which can cover the both poles of Earth. So this is something called polar orbit. So we called it polar orbit, and when we talk about the height of it, so this is the height from surface of Earth to this path or this orbit. It is around to 400 kilometer to 800 kilometer. So this height is maximally used part of polar orbit, and by this characteristics you know that it is the closest orbit to the Earth because very near 400 to 800 kilometer and high orbital speed. When we talk about the orbital speed, it means the satellite moved around the Earth by speed is orbital speed, and the use of this one is for Earth observation because you are placed very near to Earth's surface. So this one is helping you for Earth observation. Also there is a weather monitoring, like you can monitor the weather of Indian and other countries over it, and with the scientific research we also use it. There is a ISS, and maybe you all guys know that ISS is placed at 400 kilometer above the surface of Earth, and there is a low latency in communication. Latency means the time that can be presented between the receiver and sender. So the communication have very low latency because the satellite are placed very near to Earth. So this is your low Earth orbit. We also called it polar orbit. The next one, it is known as mid Earth orbit. And if I am talking about the whole area, so this is something lie between 2000 kilometer to 20,000 kilometer area from the surface of Earth. So this region is known as your mid Earth orbit or medium Earth orbit, and this have the largest covered area than LEO. Yes, this is a true statement, because as you go from more height from the surface of Earth, you can cover the maximum area of Earth. But this area cannot be used maximally because this one is used only for the navigation system. As you know that GPS which is basically American navigation system, global GPS, and this is positioning and timing use services. So we use the GPS. Inside the GPS, we are placing 24 satellite on it, and these 24 satellite are something present around 20,000 kilometer of height. So this is the use of MEO. For other reason, MEO cannot be used maximally because we use for observation of Earth, that is polar orbit, or maybe we can say the low Earth orbit. But the maximum used area for communication is your third orbit. And when I'm talking about this third orbit, this is known as geostationary Earth orbit. First, you can see the image. So if you can see the image, so this is the line of equator, and straight to the equator, there is a circle present around the whole Earth. So straight in front of the equator, there is something, a circular area, which have a exact height 35,786 kilometer. But we normally use the word, it is around 36,000 kilometer. So 36,000 kilometer in front of the equator, there is a circular path around Earth, which is called as your GEO. And this is the maximum used area, maximum utilized area. What are the characteristics behind it? Why we use it maximally? Because satellite appears fixed over one point. This is the most important one. When I'm talking about the fixed part, this is due to the rotational time period. You know that as you go from surface of Earth to the height of space, then you find as you go away, the circulation time period of a satellite can be increased regularly. Because if you are present near to Earth, you can complete one cycle in very short time period. But as you go in beyond the limit of near places, so you are much far away from the surface and you have complete a very long circle. So time taken is also very high. But exact 36,000 kilometer height is very strategic, because when you place something as 36,000 kilometer, it can complete its one circle in 24 hours. And you might be know that Earth also revolving in its own axis at 24 hours. So the satellite can complete its one rotation in 24 hours, and Earth also can rotate in 24 hours. So both are synchronous to each other. Like you can just imagine, if my face is Earth and my nose is related with equator, and I can just send a satellite in front of my nose. So this arm length is related to 36,000 kilometer. And when you can fix this, like you can launch it in front of equator, and if this one can move around this, so both are moving in the same time. Like me, Earth also rotate one axis in 24-hour time, and also this satellite can take 24-hour time. So if I can launch it in front of my nose and both can rotate, so both can rotate in 24-hour time. So you can see in whole rotation, this one never go another place, this one always fixed in front of my nose. It means the satellite always focus in one place. This is the best quality of this 36,000 kilometer orbit. That's why I can say it is the maximum utilized space. When you place some satellite over this area, this one always focus in one place. So if you want something focusing over India, you can just place the satellite over this 36,000 kilometer height. So you can see the characteristics. There is a circular orbit which is present in equatorial plane. Very large coverage area, because you are going far away from the surface of Earth, so you can cover the maximum area. And this one covering about 1/3 part of Earth. So one camera which is focusing on Earth can cover 1/3 part. So we use it for television broadcasting. We know that all the communication satellite that we are using now, that is placed in geo Earth orbit, or maybe we can say geostationary Earth orbit. We also place the weather satellite because we want to see only the weather of Indian condition. So we place the satellite over this side, and long distance communication is there. So this is a very long distance, we know it. So this one is maximally used area of Earth. After this, we have to know about this major concept. UPSC is already asked the question from it, and this is very important. in this part, we are going to talk about the geostationary versus geosynchronous. And now you know that what I mean by this synchronous. So synchronous word means which is similar with time period, means the revolution time is always same. So Earth can rotate in its own axis by 24 hours, and the satellite is also moved around Earth in 24 hours. So both have the same rotational time period. So we can say this is synchrony to each other. And this synchrony is possible only at the height of 36,000 kilometers. But just imagine, in front of the Earth, in front of the equator, only a line can be present. Only a line can be present in equatorial plane, and this line have a 360-degree area totally. But this one have a limited area, like many of the countries can place their satellite. India also have more than 30 satellite over it. So this area is very condensed, or maybe we can say lots of satellite are put in this GEO area. So we also have a secondary option for it. And we also find that in front of the equator there is a straight line is there, and this straight line is known as your geostationary, we know it. But if this place is filled, then how we can use it again? Because we need the synchrony 24-hour time period. So we tilt it something in some degree. Like this one have a 0-degree angle with equator, and if you can make some angle with it, but the distance is always 36,000 kilometers. It means distance is 36,000 kilometers. And in this part, we also say the distance is 36,000 kilometers. So when the distance is same, it means both are synchrony to each other and they can cover its one revolution in 24-hour time. So I say that if you have this one geostationary, so this one makes 0-degree angle, but this one cannot have 0-degree angle. So we can say near 0-degree angle, means we make it 5-degree or maybe we make it 10-degree, and this one also can cover the 24-hour time period. So the secondary option for geostationary is your geosynchronous. We called it geosynchronous. So this is the orbital comparison with it, and this one is a very important point that you need to know. So after this, we also talk about one major thing, and that is called Sun-synchronous orbit. First time Russia can use it, and they place a satellite which can always focus on the lightning area of Earth. We know that our Earth is present in front of the Sun. So only one part of Earth, or maybe we can say the half part of Earth, can cover with light. Second part always have a night and dark area. So when the satellite can move around the Earth, it can somehow, some part can go to the light area, and also sometime it can go to the dark area. But in dark area, you cannot have a better observation or better clicking the images. So daytime clear images, but in night time that cannot be happen clearly. So we use it like if this is Earth and this part is lightning and this part is dark. So this is the line of illumination. What we called it? Line of illumination, which can divide the Earth into the lightning part and dark part. And you can just move the satellite like this, focusing on only the daytime area. So you can just revolve the satellite over the light of illumination, and then it can focus always in daytime. So this one is a very strategic, because you can see if this is Earth, if this is Sun and this is Earth, and you can see the satellite is moving around this part. So this area is in dark, this area is in dark, and this area is in light. So you can see as the Earth can rotate around the Earth, so this line is placing and change its pattern. So line is placing now. So as the line can change its place, so satellite is also moving around this line. So when we say this area is light and this area is dark, so as the line of illumination can change its place, so satellite also move around this. So you can see, but always looking at the front of light area. So this is the main characteristic of your Sun synchronous orbit. So satellite passes over the same location at the same time, but in solar time. Consistent lightning conditions are there. Orbit plane slowly rotate to the match Earth revolution around the Sun. So it can also change its place. The satellite is very strategic, and we use it for remote sensing. Remote sensing means clicking the clear image of Earth, and also for the environmental monitoring is there, mapping and recognition is there. So these are the simple thing that we are using with SSPO. And this is the rotation of Earth. You see in this image, this is the line of illumination, and you can just rotate your satellite around this line. So this is called SSO. And why I called it SSPO? Because this is also a polar orbit. Means we place the satellite around 400 kilometer, 600 kilometer, or maybe with 800 kilometer. Clear? So these are known as your type of different orbits. And now we go to talk about how we reach these places, how we launch our satellite. So this is your first part, and that is called your PSLV. We know it. The most important one is PSLV. So we have PSLV, GSLV, Mark III and SSLV, very important one. But when we talk about the PSLV, ISRO gave it a very simple name, Polar Satellite Launch Vehicle. And what is the purpose? It is designed to mainly place the satellite into the polar orbit, because we give it the name called polar satellite, and also for the Sun-synchronous. And now you understand that why I called it SSPO, which is used for the Earth observation. This is your PSLV. But look at the structure of PSLV. So PSLV is made by 4 stages. So it is a 4-stage rocket. And the first stage is always solid. Solid means solid fuel is there. Second stage have a liquid. Third stage have a solid again. And fourth stage with have a liquid engine. But you know that why we talk about the solid and liquid fuel? So there is only one thing, that solid fuel never have in control. But this one give you maximum thrust for uplifting from Earth. Because when the rocket is launched, it is needed to balance the gravity of Earth. So we need the maximum power. And that's why we put the first stage as solid fuel. So you can see this solid fuel provide you the high thrust and helping in the liftoff. But the second stage, liquid fuel, give you the better control over it. And if the rocket cannot manage with the space, not manage the path of it, so you can handle it by liquid engine. So liquid fuel allow the better control. Again the solid fuel, because if you need again a very big thrust, so you can blow with solid fuel. So it is efficient in near vacuum. And the last one, again for balancing and controlling, there is a liquid fuel. So you have to know about this first stage and second and third and fourth. What is the sequence? So first and third have solid fuel, but second and fourth have liquid fuel. This is very important. And when I'm talking about the physics idea around it, so you know combination of solid high thrust and liquid for high control. You need to just this line in mind, that solid means high thrust and liquid means better control. So this is the strategy behind the PSLV. And you know that PSLV have a very good success ratio. If we skip the near 2 flights, so around 60 plus flights are there and only 3 are unmanaged, or maybe we can say unsuccessful. But more than 90% success ratio with PSLV, which is the best in world. And that's why ISRO can call it the power horse of ISRO. So this is called as the workhorse of ISRO, very high success ratio. But now we have the big one, and this one is known as your GSLV. GSLV have totally a different design, GSLV Mark III, or maybe we can say LVM3, that both have the same name. This one is a very different, because we shift the first stage into side. We shift the first stage into side, and this one is the second stage, and this one is third. But this one is very strategic, very important, because firstly we are using the indigenous made our cryogenic engine in it. So this one is made by cryogenic engine, but this one have a very big power. So what is the purpose behind it? So it launches the geosynchronous transfer orbit. This is called GTO, and GTO is the place which is used for placing the satellite in GSO. So when you want to place the satellite in geostationary or geosynchronous, you need to leave it in GTO. So GTO is the place where we reach by GSLV, and there is a 3 stages. So first one, there is a 2 solid strap-on booster. Strap-on booster means they are helping in uplifting. So first one is a solid booster present inside. But when we talk about the second one is a liquid core, and most important one, the third, that is cryogenic upper stage. Cryogenic engine is always present in upper stage, which is very powerful, and you know that a very secret technology. India become the 4th country which can have this cryogenic engine, but own made indigenous technology. And in this part we are using the liquid hydrogen and liquid oxygen. And we also talk about the fuel system in detail in this video also. So let's move and talk about the next one. You know that by the high success ratio of PSLV and by high success ratio of GSLV, when ISRO can get the international reputation, then we open the doors for other countries that you can carry your payloads, or maybe we can say carry your satellite, and we can launch it in a very minimum rate. So India opened a commercial wing for it, and that is called NSIL, New Space India Limited. But when New Space India Limited can do its function, we need to do some very basic and small launch vehicle also. Because most of the countries want to launch their small satellite into just near place, 400 kilometer, 600 kilometer polar orbit. So why we use the PSLV and GSLV like big launch vehicle? We use some small one. So we made a small one, and this one is known as SSLV. And what is the purpose behind it? Because we are in the commercial market of launching satellite. So the purpose is, it is quick, low cost launches for a small satellite. And you know that how much it can quick? So it is prepared for launch within 72 hours. So ISRO prepare it within 72 hours. This is a very specific thing. And by this, we know that NSIL and ISRO have a capacity to launch 3 times in a week. This one is a big capacity by India, and this one is given by SSLV. And we made it as a low cost because in 3 stage, 1 liquid terminal stage, and all the things are filled by solid. So you can see solid motors give rapid acceleration, while the final liquid stage ensure accuracy. So in the first stage solid, in the second stage solid, but in third stage we filled the liquid to balance the path. So this one is a very important for India, because when we entered into the commercial market, commercial launching, so we need a small vehicle also, and this is your SSLV. Clear? Now we move to next part, and now we talk about the rocket fuel system. Rocket fuel system is a very specific, very secret technology when we talk about the cryogenic, but solid and liquid fuel are something very basic. But we need to know about the key fact around it, because your examination can ask about the basic feature. So when we talk about the solid fuel, and we called it solid propellant, so this fuel is mixed with oxidizer, and they are mixed together in solid form. So the fuel and oxidizer, which is helping in burning, that is mixed together. This is your solid fuel. It is stored inside the rocket motor casing, and it ignite once. So once you ignite it, you cannot be control it, because the solid fuel can burn very instantly, and it gives you a very high thrust to uplift. So this is very important one. When I am talking about the properties, so you have to focus on this point. It have a simple design and high reliability, long shelf life, easy storage, but no control after ignition. This is a bad thing. And lower specific impulse than liquid engine. Liquid engine can last up to hours, but this one can burn instantly. This is the basic difference. So when we talk about the next thing, combustion control. So it is controlled by grain geometry, not by the valves, because valves are used in only liquid engine. So if the statement is come into your mind, how we control it? So for solid, there is no control and no valve systems are there. But common solid propellant, what we are using? The first one, ammonium perchlorate. This is the oxidizer. And the second one, ammonium powder. This is the fuel. And polymer bender, that is called HTPB. So HTPB is basically known as your solid fuel. The examples, first stage of ISRO's PSLV, that is of solid, and strip-on booster, which is also the first stage, but in GSLV. These are made by solid fuel. So these are filled by your solid fuel. But when we talk about the liquid one, what is the basic feature? So there is fuel and oxidizer, which is stored in separate tanks, because now we cannot mix it. So what is the major difference? Both liquid and solid fuel cannot mix together, they are just separated. But in solid fuel, both oxidizer and fuel are mixed together. So they are separated, and it is mixed when the combustion is required. So during firing it can be mixed. What are the properties? So there are throttle control possible, there is a limited control, can be shut down and restart. This is the most specific property. This one is the most specific property that ISRO also testing this kind of the thing many times, because it is very required for the future missions. This engine can be start, again stopped, and again restart. This capability we can get only with the liquid one, because once you ignite the solid, you cannot control it. Next, higher efficiency than the solid fuel, we know it. It can last up to hours. And complex design, there is pumps and valves, so we need to balance it, because as you know, is the second flight near us can be unsuccessful due to the dysfunctioning of valve. So this one is a very important and secret, and you can say complex technology. So there is also a risk of leakage in landing and hazards. So leakage problems are there. So this is the problem, but we can manage it. We are having a good control over liquid engine. Combustion control is there because we control the flow rate of fuel and oxidizer. So we can also control it. But which kind of the propellant liquid are used? So nitrogen tetroxide for oxidizer and UDMH or maybe hydrogen for the fuel. Clear? Example, second stage of PSLV is basically liquid stage, and earth storable earth sortable engines. This can be used in liquid type. Next one, when we talk about the cryogenic fuel, this one is a very secret technology. India can get it in 2014, you know that. The first cryogenic engine which is made Indian basis, that is in 2014. And what are the basic features? Uses the liquefied gases at extremely low temperature, because cryo word define the extreme low temperature. Cryo word means extreme low temperature. And when we talk about it, there is a liquid hydrogen and liquid oxygen is there. And you know that liquid hydrogen minus 253 degrees Celsius, and liquid oxidizer means liquid oxygen, that is in minus 183 degrees Celsius. What are the properties? High efficiency, we know it. Produce very high thrust per unit mass, very high thrust, so the speed and distance can be covered in very short time. But there is a problem. It is an extremely complex technology, because one side you can maintain the extreme low temperature and one side you can burn it and get it with a high temperature. So the difference of temperature is high, and that is manageable. Required insulation and precise temperature control, because this is the big problem. Next, temperature minus 253 and minus 183, we know it. Mainly the water vapors, environment friendly, because it cannot produce any kind of the bad thing. Cryogenic upper stage, which is ISRO GSLV Mark III, or maybe we can say third stage, upper stage or third stage. But why we need the cryogenic fuel? Why it is more important? Because it produces very high exhaust velocity, great efficiency, ability to carry the heavier payload. This is our actual requirement, and required speed to close escape the velocity. Means Earth gravitational pull can be balanced very easily by cryogenic. So this one is a very important and very strategic. And in the next part, now we are going to talk about a very important and specific missions which is done by ISRO. But the first one, which is our aim, and that is our Gaganyaan mission. You know that the Gaganyaan is known as the first manned flight mission that ISRO want to do. And by this, we also want to gain the capability to send a human in space and also the better control in space technology. So Gaganyaan, it is the India's first human space flight program, and this is an ISRO mission to send 3 or 4 astronauts. Now it is confirmed we select 4 person but send only 3 persons, and for 5 to 7 days mission into the low Earth orbit. So we want to send the person in low Earth orbit and they can stay for 5 to 7 days, 300 to 400 kilometer. This one done by HLVM3, and this one is a new name, but this one not a new name. H word is only for use of human flight. So human LVM, LVM means GSLV Mark III. So this one is done by your GSLV, and India's astronaut will be called Vyomnauts, or maybe we can say Gaganyauts. So Gaganyauts and Vyomnauts are the name given by ISRO. What are the key technology? So in this Gaganyaan mission, actually we have the 4 flight, and in 3 starting flights we only send the robotic system to the space, which can study the impact of environment inside the aircraft and also outside the space. And then in 2027, for 2027 we are planning for sending the humans. So before sending the human, we have 3 flights, and this is your crew module, atmospheric re-entry, because we want to maintain the re-entry impact, and also the crew escape system. Like if there is a problem, then escape system can be helping to save the life, and there is an environment control and life supporting systems are there. So these are the key technologies that we are using in Gaganyaan. And importance क्या है इसका? So this will help us better understand space and Earth, because we want to study the atmosphere around it and also the structure of Earth. So we also need to maintain the capability for human flights. This is also related with national pride, because when we talk about the world, so India become the 4th country which can gain this capability to sending the human in space, after the country like USA, Russia and China. And it will boost the morale of scientists, because our scientists can using many experiment for gaining this capability. So this one can helping in boosting the morale also, and also it can encourage the Indian industries which can relate with space technologies. So this is the importance, and this is the mission which can done by ISRO. Very important one, Aditya L1 mission, because this mission is related to the study of sun. So when we talk about the Aditya L1 mission, the ISRO mission, so study of sun, which is launched in helio orbit. And you know that the geo orbit word is used for orbit for Earth, and helio word is used for orbit for sun. So it is launched in 2 September 2023 in the Lagrange point. Don't worry, we will discuss the Lagrange point. So this one is called as Lagrange point 1, short form L1 point, and this one is done by using the PSLV XL C57. What are the objective? So this mission want to study the sun corona. Corona means energy flares, chromosphere and photosphere means lightning atmosphere and chemical atmosphere of the sun. Study the particles emitted by the sun, and also changes in the magnetic field. So sun is very important to study. So magnetic field, emitted particle. And when we talk about the L1, L1 is the Lagrange point, which is present 1.5 million kilometer away from the Earth. NASA and ESA are the only two space agencies that have the established observatories at this point. So after NASA and ESA, we are in the third number, which can place some observatory over it. Aditya L1 mission have 7 payload. This one is also very important. 7 payloads are there. First one, that is called visible emission line, and this one is related with the visible light related with sun. Solar ultraviolet imaging telescope for ultraviolet managing, means ultraviolet radiation observation. Aditya solar wind means this one related with solar wind particle experiment. There is also the analysis of plasma because sun have the plasma. So there is a plasma analyzer package for Aditya, and there is a magnetometer which can study the magnetic field produced by the sun. So these are the things related with your Aditya L1, and these are the Lagrange points. Actually, Lagrange was a scientist which can develop some points near to the sun. This is sun, this is earth, and you can see L1 point is present between earth and sun. So we are placing the Aditya L1 over it. L1 point is present in front of the sun, but L2 point is behind of the earth. As the same way, L3 is present behind the sun, but L4, L5 is present in other directions. Now we are placing the satellite on this place. So this is Aditya L1. Clear? So these are known as your Lagrange point. And now we are going to talk about our most important mission, that is providing a very pride for India, for ISRO also, that is Chandrayaan 3. And you know that by this mission we reach at the south pole of moon, very first time, the first country. India's third lunar mission, because we already done the first and second Chandrayaan mission. It is follow-up mission to the Chandrayaan 2, because in Chandrayaan 2 we want to put lander and rover over the surface of moon, but it can be not soft landed, it can be crashed. So launched by 14 July 2023 by LVM-3, and from the Satish Dhawan Space Center, Sriharikota, successfully soft landed on the moon. We know it in August 23, and we called it as a National Space Day. This is a very important one, because the landing day is known as your National Space Day. It consists of a lander and rover, we know it. We are placing the lander and rover and a propulsion module. So India became the fourth country in the world to achieve soft landing on the moon after USA, Russia and China. But as in the reaching South Pole, we are the first country. So India became the first country in the world to achieve the soft landing on the moon's South Pole, because this is the faraway point that cannot be seen from Earth. So when we talk about the objective, what are the reason behind it? So we achieve a safe and soft landing of the moon surface, move the rover on the moon surface, and also conduct the in situ scientific experiment. This word is very, very important. In situ means in this mission, we cannot carry the sample. Our lander and rover just collecting the sample, doing the experiment only on the surface of moon, and only the data can be received from the moon. So we only receive the data, not the samples. This word is known as your in situ experiment. Clear? Very important one. So this is something very important to know. And when I am talking about the lander and rover, so basically your lander is made a controlled soft landing on the moon's south pole. It carries 4 payloads. There is a Rambha payload is there. Casta payload is there. What is the Chandra surface thermographical, means it is related with the temperature experiment, and also with the ELISA, lunar seismic activity. There is a more important activity that is called seismic activity is there. And rover basically helping in movement, and this one moves on the moon surface carrying 3 payload. For alpha particle, X-ray spectrometer APXS and LIBS, basis of laser induced breakdown spectroscopy, because we want to know about the laser particle also, alpha particle also, X-ray experiment, and this one is observed by your rover. So lander and rover both have different kind of payloads, and you just need to know about the names. So this is something related with your ISRO's mission. And now if I am talking about the question, so already your prelims can ask a question in 2018 related with this context. So you have to study the statement. With the reference to India's satellite launch vehicle, consider the following statement. First statement, PSLV launch the satellites useful for the Earth resource monitoring. So Earth resource monitoring is the keyword, and PSLV launched the satellite for this purpose. Okay. Whereas GSLV designed to mainly launch communication satellite, we know it because communication satellite are placed at 36,000 kilometer height. So we send it by GSLV, but PSLV for Earth observation, and this one placed at 400 to 800 kilometer height. So this statement is true. So this statement is true. Second statement, satellite launched by PSLV appear to remain permanently fixed. Appear to remain permanently fixed. No, this is not possible because we want to fix the satellite. So we must launch it at 36,000 kilometer height, and this one is done by GSLV. So this statement is incorrect. This one is incorrect. GSLV Mark III is a 4-stage launch vehicle with the first and third stage using solid rocket motor. You know that this is GSLV Mark III, and this one have a very different design, where I tell you the first stage is shifted inside for supporting motor, and second and third stage are base. So this is not a 4-stage rocket, this is 3-stage rocket. So this statement is also wrong. And this question is asked about the correct one. So your answer is only 1. Clear? So you might be consider the statement with the topic, and this one helping you the better understanding of space technology concept. And at the end of this video, I give you a simple question for your practice, and you can just read it and also give the answer in this video comment box. So thank you very much, and thank you for watching.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.